So topic 4 covers finding solutions of a linear equation in two variables, or it's probably better to say finding solutions to a linear equation in two variables. In the previous video, we talked about, hey, we have this ordered pair. Is it or is it not a solution to a linear equation in two variables? And that was pretty easy to do. We took the x-coordinate and the y-coordinate, plugged them into the equation. If we got a true statement, we knew it was part of the solution set. If we got a false statement, that ordered pair was not part of the solution set. Here, we're kind of just jumping right to it. We're like, okay, we need to find very specific points that we know are solutions to the equation. So essentially what you can do is you can choose any x or y value, plug that single coordinate into the equation, solve for the remaining variable, and that tells you the opposite coordinate. So for example, if I were to say, hey, x is blah, plug it into the equation and solve for y, whatever we get for y has to be married to that x coordinate. Those two things have to go together to very specifically be a solution to that linear equation in two variables. So the steps for finding ordered pair solutions: select a variable for one, or select a value for one of the two variables, substitute this value into the equation and solve for the other variable, and then the values for the two variables will create an ordered pair solution. Okay, so we're just kind of getting right to it. We want to find specific points that we know are solutions. And then you can organize these ordered pair solutions into it's like a little chart that we call a table of values. So let's go ahead and look at example 5. So example 5 says fill in the table of values for each equation. So both situations, I have a table of values that's partially filled in. Now, sometimes you have a blank table of values and you just have to go completely from scratch. But in this case, we're kind of starting easy. You got a table of values that's halfway filled in. We need to fill in the remaining coordinates so that each row of the table is an ordered pair solution. Okay, so for part A, we have the equation y equals 2x minus 1. And then we've got our table of values. In the very first row, we've been given an x coordinate of -3. What we need to do is find the corresponding y coordinate so that we have a point that we know is on the line. Okay? So I'm going to take my equation, which is y equals 2x minus 1. But when I see the x, I'm going to replace it with a -3. And then we're just going to solve for y. So in this case, we just need to simplify the right-hand side of the equation. So I know that 2 times -3 is -6. And then if I subtract 1, I get that y is equal to -7. So that tells me for this particular equation, if x is -3, y has to be -7. All right, so that's our first one. And then each row, you just kind of lather, rinse, repeat. Okay, so for the second row, this time they've given us a y coordinate. We now need to find the corresponding x coordinate. So when I rewrite the equation, I'm going to replace y with -3. And then I'm going to solve for x. And in this case, solving for x is going to be a little more involved. We have to go back to what we talked about in the previous chapter where we're solving equations in one variable. So I've got this 2x. I need to get the 2x by itself. Okay, the issue is this -1, so I need to move the -1. I do that by performing the opposite operation. So I'm going to add 1 to both sides. On the left, I have -3 plus 1. That's just -2. And then on the right, the -1 plus 1, that just becomes 0. So we say it cancels. And I'm left with 2x. Now, I need to get the x by itself. So I have to undo the multiplication of 2 and x. So I divide both sides by 2. On the right-hand side, 2 divided by 2 is just 1, which leaves me 1x. And then on the left, I had -2 divided by +2, which is -1. So that tells me that for this equation, if y is -3, x has to be -1. Okay? So we're just going to repeat. The last 3 we'll do maybe a little bit quicker. So we have that x is 0. So I take the equation. Anywhere I see an x, I plug in a 0. Well, 2 times 0 is just 0. And then 0 minus 1 is -1. So if x is 0, y has to be -1. Okay? The fourth row has that x is 1. So I get y equals, well, I get 2 times x, which is 1, minus 1. 2 times 1 is 2. And then if I subtract 1, I get 2 minus 1 is just 1. So if x is 1, y also has to be 1. And then finally, for the last row, we have that y is 7. So I get 7 equals 2x minus 1. I need to get the 2x alone, so I'm going to add 1 to both sides. So let's see, that gives me 8 equals 2x because 1 minus 1 or negative 1 plus 1 is just 0. And now to get the 2x and 2x equals 8, solve for x, we just divide both sides by 2. I need to undo that multiplication of the 2 and x. So I divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. And then 8 divided by 2 is 4. So now we're saying that if y is 7, x has to equal 4. So let's look at a couple of things here. There's a website called Desmos that we can use. Where is it here? All right, so we want to look at Desmos. So Desmos.com is just a graphing utility, and it's really easy to use. We would just type in the equation. So remember, we had y equals 2x minus 1. So I'm literally just going to use the keyboard to type y equals 2x minus 1. And look, it creates a line for us. So it looks as if graphing is as simple as that. But let's test some of those points that we just found. So we decided that if x is negative 3, y would have to be 7. So we can zoom out a little bit. So we have x right here is 1, 2, negative 3. We drop down, and bam, we can see that that point, negative 3, really does equal 7. So if x is negative 3, y has to be 7. And you have to kind of get right on that point. I had it. There we go. We also had that if x is negative 1, y has to be 3. And there we have it. We had that if x is 0, y had to be negative 1. So we have that one. We also had that if x is 1, y is 1. Let me see if I can get it. There we go. And then finally, if x is 4, y is 7. So we can see right here that we were good to go. Okay. So you can use Desmos to kind of see, hey, if we were to plot those 5 points, we would get this line right here. So let's go back to the equation. We're going to look at part B. Okay, now part B is a little more involved in the sense that the coefficient on x is a fraction. So I'm showing you this one very, on purpose so that when you have to fill in a table of values from scratch, you kind of know the trick. So if you have an equation that has been solved for y, and the coefficient on x is a fraction, when you choose your x values, choose x values that are always divisible by the denominator. So right here we have y equals negative 3 halves x plus 2. Notice the denominator of my coefficient on x is 2, and notice all of the values that I chose for x are divisible by 2. That was by design, that was planned out, because if you have values that are divisible by the denominator of your fraction, your results, your y values, will be nice integer values, so you're not having to worry about tons and tons of fraction values, okay? So again, this was chosen, it was by design. Now let's get to it. So we're going to choose x to be negative 4. We'll figure out what y is. So I get y equals negative 3 halves times negative 4. I'm going to go ahead and put my negative 4 over 1 just so I have a fraction. And then I need to add 2 to all of that. Now, here's where having chosen values for x that are divisible by 4 is really nice. When I multiply across for this fraction, I get negative 3 times negative 4 is positive 12. And then I get 2 times 1 is 2. And 12 divided by 2 is just 6. So I get 6 plus 2 is 8. So I was able to get a nice integer value for y. And just like in part A, we're just going to kind of lather, rinse, repeat. So we've got the same equation, but this time we want x to be negative 2. Well, negative 3 times negative 2 is 6. 2 times 1 is 2. And it just so happens that 6 divided by 2 is 3. So I know that that's a 5. So again, by choosing x values that are divisible by 2, when I multiply by that fraction that has a denominator of 2, everything kind of simplifies out to where I get these nice integer values. It's easier to plot integer values than fraction values. That's the reason we try to avoid the fractions if we can. We're going to do another one. Let's see. This time we're saying x is 0, so I get negative 3 halves times x, which is 0 plus 2. Well, it doesn't matter what you multiply by 0, you're always going to get 0. So 3 halves times 0 is just 0. And 0 plus 2 is 2. Whoops, that's supposed to be equals. Let me fix it. All right, next we have x is 2, so negative 3 halves times 2 over 1. Well, now negative 3 times 2 is negative 6. 2 times 1 is 2. And let's see, negative 3 divided by 2 is, or negative 6 divided by negative, bless my heart, negative 6 divided by 2 is negative 3. And then negative 3 plus 2 is negative 1. And finally, we have x is 4, so I get y equals negative 3 over 2 times negative 4 over 1, or positive 4 over 1, sorry. Over here, plus 2. So when I multiply across, negative 3 times 4 is negative 12. 2 times 1 is 2. Well, negative 12 divided by 2 is negative 6. And negative 6 plus 2 is negative 4. So by choosing very specific x values, I could choose any value for x I wanted, but I specifically chose values for x that were divisible by 2 so that I would get these nice, pretty y values out. Now also notice my x's are increasing by 2. So I go from negative 4 to negative 2, that's adding 2. Negative 2 to 0 is adding 2. 0 to 2 is adding 2. 2 to 4 is adding 2. But then notice what's happening with my y's. I went from 8 to 5, which is subtracting 3. 3 to 2, which is subtracting 3. 2 to 1, negative 1, which is subtracting 3. And negative 1 to negative 4 is subtracting 3. So if I look at my slope, I had negative 3 over 2. Well, that shows me that I'm dropping 3 for y every time I increase x by 2. So that slope really means something. So notice your x's are increasing by 2 at the same time your y's are decreasing by 3, and that looks very much like your slope. So, or your slope very much looks like the coefficient of your x, which is the slope. We'll talk about that in a future video. Excuse me. So for this video, just know that you can always find a group of solutions to a linear equation. And what we're going to look at in the next topic is how to do something very much like this, but then to follow it up with one extra step where we actually get a graph for that particular equation.